Today I'm going to talk to you about composites because we are going to make a composite material and test it. So here's some advantages of composites, things you'll want to note down into your engineering notebook. One is a strength to weight ratio. Usually has a very good strength to weight ratio, a longer life than maybe a typical some other materials. It's useful for dampening vibrations because it's made of multiple different materials with different vibrations, oscillation points. Easy to repair and shape. They have tailored strength characteristics, and they have really good resistance to corrosion. So let's take a look at some specifics here. Composite materials must have two basic parts. They have a reinforcement and they have a matrix or resin. So the reinforcement for us is going to be fiberglass, and this resin is kind of this little mixed piece that we're going to sort of brush or pour onto the top of it. All composites must have an identifiable reinforcement and matrix. So ours is going to have a reinforcement, a matrix, and styrofoam that will go in between the two layers of that. So reinforcement, again, provides the majority of the strength. And that's that resin that we're going to use. The matrix holds the reinforcement in a specific orientation, and it improves environmental properties and provides some strength. So we're going to be doing some testing, some strength and stress testing on our composites. Fiberglass is the most common, so we're going to do a fiberglass and styrofoam composite. So it's a fiberglass composite with styrofoam sandwiched in between it. Graphite has a good strength to weight ratio. Kevlar is the toughest, boron the strongest. Silicon carbide is a ceramics reinforcement, which is useful in really hot applications for jet engine exhaust and things like that. But we're going to take a look at the fiberglass one. So some industries that use composites: aerospace, recreation, biomedical, transportation, infrastructure, and construction all use composites. They would use composite material on these boats. It's lightweight, very strong. These materials can be toxic. So when you are creating your fiberglass composite, some areas of risk that you really need to pay special attention to are your eyes, your skin, and your throat, your respiratory system. These liquids are resins and solvents, so it's bad to just inhale or breathe in. So you're going to want to make sure you have good ventilation. We don't really have dust or particulates, but that can get into your eyes. However, some of the fiberglass fibers really can cause some pain. So if you're having some eye problems, these may be some of your problems: watering eyes, redness, swelling, itching, and burning sensations. And so you are going to want to wear visual protection. And so for the thing that we are going to use is we have some safety glasses in the back that you're going to be required to use when you're mixing up with the resins. The skin risks for the fibers: when you're using fiberglass, if you just handle it, it's going to feel like there's nothing to it. But it's little tiny glass fibers, and over time and a lot of handling, they are going to start to dig. These fibers are going to come off and dig their way under your skin. You won't even see them. You won't even know it's there until you're like, wow, my hands just kind of hurt. And they will, because you have little glass fibers in them. And the only way to get them out is to fast forward through time. So that's why you are going to want to wear gloves for that. So skin problems: redness, rash, itching, burning, dry, or cracking skin. And cover your skin. So we're going to have some gloves for you when you do this. Also, when you're handling the resin, you're going to want to make sure you have gloves on to protect yourself as well.